Welcome to this video. In this video, we are going to see about the experiment called determination of coefficient friction in pipes. As we already seen about the flow rate using a rotometer, venturimeter, and RSF meter. Here we are going to consider the friction rate when the water gets flow through the pipe. Here we can divide it as in two parts, which is also called as a losses in two variation. One is called a major loss and another one is called minor loss, which is your another experiment. Here we are going to see about major loss through pipes. The losses will be vary, the frictional resistance will be rise, depends upon the length of this one. As you see, it is a length, a loss length of 2 meter pipe. This total setup will contain a 2 meter length pipe for this experiment. First, we as compared to that RSF meter and venturimeter, here also we are going to use this YouTube manometer, which will help us to identify the different head of the discharge. So for this, we first, as if we seen in this previous experiment, we have to level this mercury level in the YouTube manometer by using this valve to open this valve simultaneously, which will help us to level the mercury level in your YouTube manometer. You must to have used this in simultaneous manner, or else it will get changed in your YouTube manual. The reflection will be in your YouTube manual. We have to do multiple times. So it is better to you open the valve and close the valve in a simultaneous manner. First, here we are going to calculate the different head levels, and again we have to calculate this is the collecting tank, which is the area of 40 into 40 centimeter. Again we are going to calculate the time taken for your 10 minutes rise in this tube. This is the readings we have to take in this experiment. Afterwards we can see in the calculation part.
To identify the coefficient friction in the pump, first we are going to note down the diameter of the pump, length of the pump, and the internal plane dimensions of the collecting tank. After note downing this, we have to note down the H1 value, H2 value in the manometer, and time taken for 10 centimeter rise of the water, which can also be write as 100 of the rise of the water. After note down this, we have to identify the actual discharge, which is the same formula again. Q actual is equal to A into R divided by T. A into R divided by T. R or H, both are the height height of the water collected in the tank, which is 10 centimeter. And we are to identify the area of the pipe. We are going to use this formula. A is equal to pi d square divided by 4, and internal plane area of the collecting tank L into B. Afterwards, we are going to find the velocity, which is equal to Q actual divided by A. A is A is the area of the pipe. Afterwards, we are going to find the coefficient of the friction. For this, we have the formula F is equal to 2 into G into D, 2 into G into D into HF divided by 4LV square. Here the G is nothing but acceleration of due to gravity. D is diameter of the pipe in meter. L is length of the pipe in meter. V is the velocity of a liquid flowing in the pipe, and HF is equal to loss of head due to friction. For this loss of head due to friction, we are going to use the formula which is similar to Orosif meter, the calculation from Orosif meter. HF is equal to H1 minus H2 into SM divided by SW minus 1. Again, SM is equal to specific gravity of mercury, SW is equal to specific gravity of water. After calculating this, we have to plot a graph for HF value versus V square, where V square is considered, which is velocity is considered in the x-axis. Mm, from this, we can identify the actual coefficient of friction